So I'm going to start with a little bit of a pop quiz. So we're going to get a little bit interactive. There's a scenario. The phone rings. It's the middle of the night. Your website is down. Everyone on your engineering team is out of cell phone range, so it's just you. Raise your hand if you feel like you know what to do or where to start. Pretty good, pretty good. Now I want everybody to close their eyes, and I want you to raise your hand again. No one is going to judge you. Just, raise it up if you feel like you know what to do or where to start. I'm happy to see that most of you are pretty honest. So yeah, my hope is that by the end of this talk, those that didn't raise their hand will come away with some ideas on how to get more comfortable around site availability. And for the rest of you, hopefully you'll get a refresher and you'll come away with some ideas for your teams and people who maybe aren't as confident. So one of the big challenges that I found with site availability is that most of the time it catches us completely off guard. So on a day-to-day, you practice writing code, you practice refactoring, testing, all these things. But a site outage kind of comes from a lot of different random reasons, and it usually comes out of left field. So this randomness can be just a little bit scary. And I'm going to start off by telling my scary story. It's July 2015. I'm working as a Ruby developer for Indiegogo, which is a crowdfunding website that I work at now. And it's a site where people come to fund things that matter to them. So we've had a lot of successful campaigns. We get quite a bit of traffic. So we have an Australian beekeeping campaign that raised like $12 million, which was amazing. A campaign to fund the movie Super Troopers 2. So some cool stuff. But this was a little unusual. So on July 2015, the news breaks that Greece has become the first developed country to fail to make an IMF loan payment. And through some weird course of events, it manages to take down our entire website. So it's the middle of the night, California time. Europe is waking up, and they're waking up to this incredible news story where this really nice British guy decides that he's going to end the Greek financial crisis. And he's going to do this by launching a 1.6 billion euro campaign to bail out the entire country of Greece. And so his rationale is basically everybody in Europe throws in 3 euros, and they're done. They meet their goal, everything's over, we'll all go home. So traffic starts to build and build, and it's the middle of the night, California, and people start to contribute these small amounts at really high rates. And eventually it takes our entire website down, and it really doesn't fully recover until we're able to put up a mostly static page to handle the load. And so for me, this is completely unlike my day-to-day. So I triage bugs, I deploy, I do all of these things, but this is totally out of my wheelhouse. And honestly, I was kind of unprepared, and I was just a little bit scared. And so I wondered afterwards, how could I have been more prepared for this? Wow, that just keeps going. So load testing is a way to programmatically simulate many users making simultaneous requests to your website. So it acts as sort of a low-stress simulator for these high-stress situations. It allows you to play around, build confidence. You can come up with your own site availability playbook before any kind of disasters occur. And as an added benefit, it can also help you identify bottlenecks in your application that could be dangerous in the future, and also measure performance benefits from any changes you might decide to make along the way. The downside of load testing was really, for me when I started, there was a lot of high-level instruction around how to just kick one off. And there's a lot of very technical instruction around site performance. But bridging those two things together took a lot of trial and error and some frustrated Googling. So through the course of this talk, I'd like to talk about 3 things. 1 is how to get started. 2 is just how to turn up the volume on your load test. And 3, just talk about a couple of tools for exploring the results that you get. So how do we get started? So we'll kick things off by preparing the load testing tool. I'm going to talk mostly about Apache Bench because it's pre-installed on Linux machines, and it's really one of the simplest tools to get started with. This command, starting with AB for Apache Bench, is basically all you need to really kick off your first load test. We'll break it down a little bit further. So we'll want to choose an endpoint to send our simulated traffic to. In this case, example.com. Fun fact, the first time I gave this talk, which was like 2 weeks ago at a meetup, I used url.com. And somebody happened to mention that that is somebody's actual website, and that I probably shouldn't be telling people to like just send a bunch of traffic to it. So example.com is actually the official example web page on the internet. So anyway, you want to use a simple static page that doesn't make any calls to the database if you want to just get a baseline. And when you're confident that your load testing configuration is right, you'll want to choose a page that you anticipate to bear the brunt of your traffic. So for us, it's our campaign page. Like, our home page does get traffic, but like these campaign pages, like the Grease campaign, is where like we're really going to see the most load. And you can start by load testing localhost if you'd like, if you're just playing around. But honestly, the load test itself is a resource. It's consumed by your computer. And because it's using that resource, it will actually take away available resources from your server. And so as you increase load, you'll actually see that start to affect your results. So on the flip side, running a load test against a production website can impact user experience and even bring down the site. It's best to point to a staging server or a production server that does not host any external traffic. And because I know that at least one person was thinking it in the audience right now, yes, technically it's just DOSing yourself, but you can also DDoS yourself, so whatever. So next we'll talk about configuring the load. To finish up this command, you want to provide the number of requests that you want to execute concurrently. That's using the C flag. And the total number of requests you want to run over the entire course of your test. And that's the N flag. So we'll start with like a concurrency of 1 and enough requests that your system has a bit of time to warm up. In this example, it would mean that we would execute 1 request concurrently, and we do it 1,000 times. And you just want to make sure that it's going to run for a couple of minutes at least. And when I talk about sending through requests, like what is a single request in this scenario? It actually isn't a single visitor to your web page. So depending on the number of assets that you're loading or the number of async client requests that your front-end application is making, a single unique visitor could actually make many requests. And then on the flip side, a browser caching of assets actually means that a return visitor is going to make fewer requests. And another important thing to keep in mind is that Apache Bench and other server-side tools are not going to render HTML, and they're not going to execute JavaScript. So the latency times that you see recorded in your results are really just going to be part of your user experience. So let's take a look at the final output of Apache Bench so that we can analyze our results. So this is a snapshot of the full results. A little difficult to read, so we'll zoom in. You'll see that with Apache Bench, it'll show you the percentage of requests served within a certain time. And as you sort of analyze these initial results, you want to validate that the sort of average latency that you're seeing overall sort of is in line with the latency you would expect from an average request on your website. Like, load testing is a bit of a black box. If you just start like plugging in random numbers and you don't really understand what's happening, you can get some actually really good results and you have no idea why. So you want to just have a reasonable hypothesis for like how you would expect your system to perform. So if you have an estimate for how long it takes for your production server to return a request, it can give you a ballpark for kind of what you're expecting from your load testing setup. So for example, if we look at the line that shows the 99th percentile latency, it's saying that 99% of these 1,000 requests that we sent were served in less than 693 milliseconds. So if you have a graph available on your production server and the 99% line is showing that you're getting around 650 milliseconds, that's probably about right. But if your load test is showing that same page is 100 milliseconds, you should really be suspicious, and you should expect that you actually have an issue with your load testing setup. A common issue that I run into with load testing is that you're load testing an error page, especially if you're using a staging server for your load testing. For example, if your server requires basic auth to authenticate your requests, you'll need to add it to your Apache Bench command. Otherwise, you're just load testing your server's ability to return a 400 error. Another common issue is hitting a 500 page or a redirect. Apache Bench won't actually follow those redirects, so it'll just log it as a non-200 request. And you'll see this pretty clearly in your Apache Bench results, and it'll show non-200 responses. And in this scenario, the number is greater than 0 already without any load. You're probably running into one of these issues. And if you tail your server logs while your test is running, you should start to get a sense for like what the responses that are coming back are. It's also, you have to differentiate the non-200 responses from something called failed requests. Apache Bench will remember the content length of the first request, and if it changes dynamically in any subsequent request, so if there's like a session value that's dynamic or any other reason that your content length might change at all, it'll actually show these as failed requests. And you'll see it in your output here, but if you verify with your logs that everything looks fine, you can pretty much ignore this. And in later versions of Apache Bench, you can just add a flag, a -L flag, to just accept the variable document length. So if we feel confident that this load testing setup that we have is just like, it's doing fine, there's no errors, you can start to really turn up the volume. As we turn up the volume, we can start to understand how our app is impacted by load. Let's look first at how queuing affects the user experience. So we're going to get a little bit more technical. As we start to increase this load, the average response time of the whole site is going to increase as well. And so that's really explained by this thing called Little's Law, which is like a fundamental law of queuing theory that tells us sort of, you know, L equals lambda times W, which is like the average number of customers in a stable system is equal to the average effective arrival rate times the time you spend in a store, which is whatever. But if you like use this real-world example, you actually see that this is incredibly intuitive and very basic. So let's think about a store. There's one cashier only. The total number of customers that are waiting in that line to check out is basically the rate that they show up by how long, times how long they actually spend getting their stuff checked out. So if you have a new cashier come on duty and they're super slow, they're like twice as slow as the cashier that was checking out before, if people keep coming into line at the same rate, they're going to be waiting a lot longer. And that's basically what this law is telling us. It's really intuitive. And if you change around this equation, you can also see how the mean response time for a server would start increasing as you add additional load. So if our server takes 500 milliseconds to process a request, and that number stays steady, which obviously under load it actually probably won't, but in this example it stays steady, your total response time on average is going to increase if you add more requests to that system. And an application kind of acts like a giant queue that requests are processed in. And so in this example, we'll talk about a web stack that consists of a few things. So we'll talk about the proxy server, which sits behind your firewall and communicates back and forth between the client and the web server. A common example is HAProxy or Nginx. We'll talk about the application server, which is a web server that deals with requests that need processing. It makes requests to the database. In our scenario, I'll probably talk about Unicorn because that's what I'm familiar with, but there's obviously lots of different types of servers. And our database, which will be SQL for the purpose of this example. And so these can all live on the same physical machine, and they can all use the same resources, or they can live on different machines. It's just an example. Your web stack will probably be different, but it'll be a similar feeling of people coming through a queue and clearing through your system. And so as you add more and more requests to this queue, Little's Law is going to state that your average response time is going to go up and up. And eventually, as you add more and more, the wait will grow too long, and users will experience a timeout. And so your proxy server will basically allow a client request to wait a certain amount of time, and then it's going to eventually return an error. And as you increase the load on the system, you may be tempted to configure your application server so that it accepts more requests And that the danger here is really that under extreme load, requests can remain queued up at the application server level as opposed to the proxy server level, even after the proxy server has said, sorry, it's a timeout. And so your application server will actually keep churning on that request and wait on that request to come back, even though your user is long gone. So it goes against the recommendation of queuing theory, which basically shows that it's a single queue for multiple workers in certain scenarios is more efficient when job times are inconsistent. And to kind of illustrate that in practice, if you have two available web workers that can execute on jobs, and one is processing this really huge file and one is processing this little tiny file, if another request comes along and you just arbitrarily queue it up behind this worker downloading the huge file, that short request is unnecessarily blocked by that long request, when another worker could have done the exact same work in a smaller amount of time. So you don't want to add an additional queue at your application server level so that there's a lot going on. You might also be tempted to increase the timeout threshold on your proxy server higher and higher to sort of arbitrarily decrease your error rate. But a user that doesn't see a web page load after a couple of minutes or two will have an equal or worse reaction than just getting the timeout error. So don't do that either. And it's not just your application that's going to be affected by load. You'll also see effects at the operating system as well. These configurations might already be in place on a production machine that you're using, but if you're load testing on a staging machine, you'll find that a lot of these things aren't actually in place. So the proxy server that sits in front of the application server has to keep track of each incoming client request. And it basically does this by keeping track of an IP address and a port number associated with each of those requests. And because each of these requests uses a Linux file handle, you can start to see an error like too many open files. This is a really common issue with load testing. You'll want to make sure that your operating system on your server isn't arbitrarily capping the number of file handles available to you for your proxy server at some arbitrarily low number. So 1024 is a really common default. And your proxy server will use one file handle for each incoming and outgoing connection. So you can actually run up against this limit really quickly if you start to increase the load. You can view what these limits are for the user, aka ulimit. And to calculate a number to set, there's kind of a rule of thumb that's from the like 2.6 kernel documentation. So each file handle is approximately 1K of memory. You don't want to allocate more than 10% of your memory for this by default. So it comes out to be about 100 file descriptors for every megabyte of RAM. And you kind of start there and see if your issue goes away. You can also kind of use some arbitrary numbers and just see how it goes. Don't do that on production, but when you're load testing, you can kind of play around. So you'll also want to set, so there's two different limits. So there's the system limit, like the system-wide limit, that you'll need to adjust separately. And that's adjusted at the syscontrol level. But then you also have a user limit. And that should be a subset of your system limit, because you don't want your users to be able to consume more resources than they need to. So you'll want to have that limit just a little bit lower, and so you'll need to configure that as well. You set a soft limit, which is the default. So any application on that under that user will just have that limit by default. And the hard limit is how high up that a specific process can actually override the soft limit to. So you reload your changes and save and close the file. And you'll also want to make sure that your proxy server isn't limiting that as well. So for Nginx, it's the worker rlimit no file, but it can be different for different proxy servers. And another issue that you can run into similarly is your TCP/IP port exhaustion. So there's a finite number of ports available on a machine And so only a subset of these ports are available for your application to use. These are called ephemeral ports, and they're used to handle web requests. And once the process is complete, they're going to be released back into the wild so that other requests can use them. But there's typically a waiting period. And so you could tweak two settings to make more ports available. One is to decrease the time wait. So this is going to allow that port to be recycled back in more quickly, because even though this port isn't in use anymore, there's a period before it's made available again to prevent stray packets from leaking in across requests. And you should also, this is load testing only, you should wait a few minutes between each test run to just allow your prior ports to close and let your system kind of calm itself down. You can also configure your operating system to increase the available port range. It'll be different on each operating system. And the Unicorn documentation actually has some pretty good recommendations for operating system tuning. So the one thing to remember, too, in load testing is that your application is a special snowflake. You have to think through how your application behaves in the real world and how it might affect performance in a way that you aren't accounting for in a sterile testing environment. So one example is the relationship between user actions and cache busting and database queries. Let's say the endpoint that you're load testing returns user comments, for example. An important consideration will be the quantity of rows and the complexity of queries. So if your test endpoint that you're using has very few comments or really no comments seeded at all, but your expected user behavior under a load is that you have millions and millions of comments and they're climbing higher and higher, you'll want to keep that in mind when you're executing load testing. And additionally, even if you are returning data for a user that has 1 million comments, that query will typically be cached after your first request. So if a real-life scenario is that your user is getting 1,000 comments a second and things are just blowing up, you can actually run simultaneously a script that generates comments while you're running your load test to simulate this sort of true effect. And you might see some really different results. A final thing to consider is blocking external requests. So if you're experiencing heavy load, all of your workers are overwhelmed, and any worker that's executing is making a very slow blocking request to like payments provider, which is which is something that is very near and dear to my heart because I work on payments. It's going to add to the overall latency for any users that are waiting behind that request. So at this point, you should be pretty comfortable with a lifecycle of a web request in your stack. And you should kind of know what logs to look out for, to keep an eye out for errors. And you should be pretty confident that if you run just like a reasonable load test via your load testing environment, that you're actually not limited by your load testing framework. And once you're at this point, you could begin using additional tools to understand the bottlenecks in your application itself. So one place to start is to start by investigating the limits of the host machine where your proxy server or your application server are living. So a pretty common tool that I think a lot of people are familiar with is top. You can just use that while you're running the load testing tool to view what percentage CPU and memory are being consumed. Just one thing to keep in mind that occasionally we forget is that the percentage that you see here is just the percentage of a single CPU. So on a multi-core system, the percentage is often going to be greater than 100%. Actually, even nicer is htop, which is not installed by default, but is pretty cool. It has like a really nice visual representation of your CPU consumption across cores and also your swap memory. So it's kind of nice. And don't forget that overall, the resources on the physical machine that are hosting your proxy server, your web server, your database, it's all a zero-sum game. you want to make sure that you don't have so many workers configured that your system runs out of physical memory and starts hitting the swap memory. You can see what your average memory usage is for each one of your web workers on your machine. And if you don't have a memory leak, it's going to be pretty consistent. So if you're running other applications on the same box, like for example, if you're running Redis on the same machine, those are also going to consume resources. And also your database is another thing. If you're testing it with your database on the same machine, you'll find that you'll probably run out of CPU resources long before you ever actually see your database in your testing environment topple over. Rails is pretty straightforward to point to an external database if you have a database server handy. You can configure your database.yaml to just point to an external address rather than your local host. Just remember, please don't use your production database in this scenario because you can definitely bring down your website. So you can also use application performance monitoring tools to investigate performance issues. Many of you probably use these in production already. Transaction tracing is really the most useful tool to be looking at when you're running your load testing. New Relic, Skylight come to mind as tools that people use. Ideally, you should use the one that you use in production on your testing machine so that you can see what issues it would show in real life, just if you're trying to get more comfortable. But you could also use the Gem Rack Mini Profiler, both in production or on your load test, and has a lot of great output as well. If you're running in staging, just be sure to switch the environment to production mode, because otherwise it won't actually profile when you're running your test. You can use some tools as well built into MySQL that will help you see how your database is being impacted by load. It's disabled by default, but you can turn on something called the slow query log in MySQL to see a list of SQL statements that took more than a certain amount of time. And that can be configured from 0 seconds all the way up to 10 seconds. So if you're looking for a certain threshold, you can configure that custom. But another thing that actually bit us really hard was that you could be calling a query just way too often. It may not be expensive enough to show up on the slow query log, but you can use show process list to see all the queries that are currently running. If one query is just running suspiciously frequently, it could actually be a bottleneck, especially if it's one of those very special Snowflake queries we talked about before, where the cache is frequently being busted under load. Apache Bench isn't always the best tool on the market. Most people would say it is definitely not the best tool on the market. There's a bunch of others. Siege is another tool which allows you to configure, you actually use a configuration file to hit multiple endpoints at once, which is pretty cool. And it has a wrapper that they have called Bombard, which allows you to programmatically increase the load on your application over time. Bees with Machine Guns is another pretty cool open source tool. And it's created by the news application team for the Chicago Tribune. And it basically allows you to spin up these micro EC2 instances and to basically literally DDoS yourself and spin them down. It's pretty cool. Flood.io is a paid service, but they maintain this Ruby JMeter, which is a Ruby DSL for writing JMeter configurations. So, like I said, your app might look very different from what I'm talking about today. Your app might be hosted on Heroku. You may be using Puma instead of Unicorn. You may be using a complex, fault-tolerant distributed system. In that case, you probably have a totally different set of problems that I would love to hear about. But hopefully, load testing can give you a framework for curiosity and shine some light into some otherwise dark and scary places. Thanks, everybody. I'll tweet out a link to my slides if you're interested in taking a look. You can find me at @practice_cactus on the internet.